The focus of this video will be to work through multiple type 1 polyatomic non-acid ionic compounds, going from formula to name and from name to formula. I'm going to specifically concentrate on type 1 compounds with a fixed charge metal plus a polyatomic anion that derives from the nitric acids. Please keep in mind that if you have a fixed charge metal, that fixed charge metal is going to come from one of the following places: column 1, column 2, or the 6-pack. Let's start with this chemical formula and find its chemical name. The first step is to name the first element or polyatomic cation. I see an element. That element is sodium. So with that being said, that makes this compound a type 1 compound. How do I know that? Because sodium is found in column 1. It has a fixed charge. The second step is to name the second element or polyatomic anion. I see an anion, and I know this anion derived from the ic acids. How do I know that? Because that's what we're working on. Anions that derive from the ic acids. And what acid is that? That would be nitric acid. Nitric acid donated this hydrogen ion, and that's how this anion earned its charge, NO3 minus. So the name of that anion is nitrate. So we would put nitrate, and the chemical name would read sodium nitrate. Okay, so now we have this chemical formula. The first step is to name the first element or polyatomic cation. I know I'm seeing an element. Do not focus too much on the subscripts. These subscripts are just telling you that you have 2 aluminums. And this right here is telling you that you have 3 of the anions. Remember, if it's a type 1, it's going to fall in the green region. And I know aluminum is right here, so it makes this compound a type 1. So we name the first element, which is aluminum. And the second step is to name the second element or polyatomic anion. I see an anion, and this anion derives from one of the ic acids that you are to remember. And that acid is sulfuric acid. It goes from ic to the suffix ate to the suffix ite. When sulfuric acid donates 2 hydrogen ions, it becomes sulfate, and it gains its 2 minus charge. Then if you have 1 less oxygen, then now you are seeing at the anion that is going to end with ITE, which would be sulfite. So with that being said, the chemical name for this is going to be aluminum sulfide. Okay, so now we have this chemical formula. I see magnesium. Therefore, this compound is going to be a type 1 compound. Why? Because the cation falls within the green region right here in column 2. Next, I know that this anion derives from one of the ic acids, and that ic acid is iodic acid. Iodic acid donates this hydrogen ion, and because of that, it gets a 1 minus charge. That's what this represents. And it goes from ic to the suffix ate. So you would have iodic and iodate. And now, if the anion has 1 extra oxygen, then you're going to have the prefix per and the suffix ate. So that's going to make the anion be periodate. So with that being said, our chemical name is going to be magnesium periodate. Okay, so now we're starting with the chemical name, and we need to find the chemical formula. The first thing is to write the chemical symbols and their charges. I see calcium. Calcium is found in column 2, and it has a +2 charge. Phosphate It derives from phosphoric acid. Phosphoric acid donates 3 hydrogen ions and it becomes PO4 3-. Now, we need to cross multiply by transferring only these numbers. And we need to make sure that the total charge of the compound balances to 0. A big warning, the subscript attached to the polyatomic ion does not count toward making the total charge balance to 0. I'm going to bring this 3 over here. And I'm going to bring this 2 to the right side. 2 times -3 gives me -6. 3 times 2 gives me 6. 6 minus 6 equals 0. So I have met that requirement. And the last step is to obtain the final formula, we need to remove all charges and keep only subscripts of 2 or higher. I bring my calcium down. I bring the subscript of 3. Because we have a polyatomic ion and we have a subscript of 2, I first need to write my parentheses, and then I bring down the subscript of 2 or whatever subscript that you would have here. So with that being said, this is going to be my chemical formula. Okay, so we now have potassium chloride and we need to find its chemical formula. The first step is to write the chemical symbols and their charges. I have potassium. Potassium is found in column 1 and it has a +1 charge. Chloride. It derives from chloric acid. Chloric acid donates 1 hydrogen ion, and in the process, it gains its 1- charge and becomes chlorate. 1 fewer oxygen going down would make us have the anion chlorite. So we would have ClO₂ 1-. Since we have the same number here in the charges, then all you have to do is write the chemical symbols together to make the formula. Why? Because the opposite charges are going to cancel each other. So this is the chemical formula. Okay, so this is the last problem. You can try it yourself and stop the video. You should have gotten this for the chemical formula. Remember to make sure that the total charge of the compound balances to 0. And also remember that after cross multiplying, if a subscript of 2 or higher is transferred to a polyatomic ion, you have to place parentheses and write the subscript that is 2 or higher outside the parentheses. So with that being said, this will be your chemical formula.